Hi, ladies. So this is the first day after spring break, April 20th. It's a Monday, and we're going to be working on chapter 4 today. This is our third day in the chapter. And I hope you guys had a wonderful Easter and a nice break, and that you had some time to rest and relax and do some things you haven't been able to do while we've been going through online schooling. So I want to kind of give you an overview of what we're doing. We'll start with prayer, some updates. Prime time, we have a few things to go over. I have some homework answers to go over. Class content today, we're actually going to start some real chemistry and classwork and looking ahead. So the first thing I want to do is show you some of the prayer requests that we have here. So ladies, feel free to come into the document and add to this or modify any of these things that are up here. So just a moment for some of these special intentions. So let's start with St. Angela. In the name of the Father, the Son, and the Holy Spirit, amen. St. Angela, assist us in our efforts to respect each other, to accept each other without any desire to control or change, to help each other and to bear each other's burdens by sharing our stories and insights. Watch over us and guide us. Amen. In the name of the Father, and the Son, and the Holy Spirit. Amen. So again, the link for the Google Doc is there. Feel free to add to it as you wish. Update on the class. I don't know a whole lot more than I did when we ended break. There is a meeting on Monday morning, the 20th, with administration and staff. Should know more after that. However, I'm recording this on Sunday, so I don't know anything about what we're going to find out about in that meeting yet. Also, as of right now, there's been no information from the governor. So probably by the time I chat with you on Wednesday and film for Wednesday's class, we'll know a whole lot more. And by the time you watch this, you may know more because things have changed. So packets, I mailed packets out to the 11 students who requested them. I only received an email from one student saying that they received it, but I'm assuming everybody else did receive theirs because there's been plenty of time for everybody to have gotten it. And I've had none returned to me from the U.S. mail. So I mailed packets for chapters 4, 5, and 6, as well as some reference material. All of that is going to be posted on P-Learning for you guys who can print out to have access to. And in the packets, as well as some of the extra pages that I provided, there's many more practice pages than I expect everyone to do. As I told you in the week before break, that after a lot of soul searching and a lot of frustration and a lot of trying to figure out what the heck I was going to do, I came to the realization that I still personally feel it's important to set this class up for success next year. And in spite of the fact that COVID has been preventing us from being together, that doesn't mean that I think that I should shortchange your class. So I'm leaving out a lot of things that I would normally cover, and obviously we're really not doing a whole lot in the way of labs because we just can't. But there are still a couple of topics that I need to cover to do that. And how well you master these different concepts and these different topics is really going to be up to each of you individually. I've tried to provide enough practice in the packets that it should cover pretty much everybody, because everybody has wide-ranging ability levels, as well as how many times do they need to see a certain type of concept in order to master it and feel comfortable. So I do recognize there's a lot of paper in those mailings, but I also do recognize that I don't expect these all to be finished. So last thing, grading's current, and I've emailed rubrics to everyone, curation, as well as the 2 rubrics for the chapter 3 test. So if there's any grade that you think is incorrect in PowerSchool, you are going to need to email me. I have updated everything, and I believe I am current and up to date. So, but unfortunately, PowerSchool doesn't tell me if somebody submits something since the last time I went in, it doesn't pop up with some kind of screen that says, since the last time you logged in, this was modified or changed or submitted. I don't have any way of knowing that. So the only way I really have to go back and look at old assignments is for you to email me, and then I can look at it. All right, personal update. So I wanted to share with you some of the travels that we've done and some of the places that we've lived. And I wanted to start with Singapore because Singapore is a very interesting and unique country. It is actually a country, or also known as a city, because it is small. It's a very, very small island, and it is the size of a fairly large city, but it is its own country. So just kind of a few overview pictures today, and next time I will have a map that I will share with all of you guys and show you where this is and give you a little bit better idea of what it looks like. So we've got a very large Ferris wheel here. This is called the Singapore Flyer. We rode this one time, and they've got these gondolas that look like this. Quite a few people fit inside. And this is kind of a picture of part of their skyline. This is the downtown area. And this is a hotel with some shopping in it. There's actually 3 towers here, which you cannot tell from the angle here. And this thing on the top looks kind of like a boat, and I'll show you a side view of it in a minute. Down here is a cricket field, and I understand it's pretty much internationally known because it's like the only one floating on water. And there's also, this is a mall over here, which you can kind of see kind of peeking out from behind the gondola. There's an arts and science museum down here. But this is one of the days that we were there. And then this is that building that I told you that had 3 towers in it and something up at the top that looks kind of like a ship. It looks like a boat. I think it looks like a cruise ship. They put on a light show every night. We were sitting across the river, kind of where all those buildings were, and watched the light show one evening when we were there. This is the Arts and Science Museum. This is the mall that you could see. The Ferris wheel would be like back over here. It's just not in this picture. By these buildings where I'm actually kind of sitting at here, there is this very famous water fountain. It's in the shape of a merlion, and a merlion is a mythological creature that is common in Singaporean historical children's literature, and it has the head of a lion and the tail of a mermaid. And so when they have a lot of their shirts and cups and mugs and keychains and things like that have the image of the merlion on there. So when people see a merlion, they think of Singapore. So next time I'll show you a picture and a little bit more of the actual culture. But from all of this, you can kind of see it's a fairly modern city. It's actually a very young city, and has a very interesting past, and I'll share more with you next time. So one other thing I wanted to share with you today, since I can't do a lot of demos in class, I'm trying to find some videos, and I've actually done some demos here at home with the help of my husband. And this one is about the triple point, and this is one that I found online. So a triple point is when you can actually have solid, liquid, and vapor phases existing all at the same time. And there is a specific temperature and pressure at which this can occur. And every substance has its own very specific triple point. So the video that I wanted to show you today is one for triple point of water. And it's kind of neat. It's pretty high speed. So there we go. Water reaches its triple point just above freezing at 0.1 degrees Celsius and a pressure of 0.006 atmospheres, which is actually pretty low. And I'm having a hard time starting the video. There we go. So water's placed inside a vacuum chamber, and then they turn on the vacuum pump to lower the pressure. So they're actually sucking out the air that's inside here at the same time. So they've got a little bit of ice water sitting here, and this is just allowing it to get started. And as the pressure drops, you'll be able to start seeing some bubbles. So you can see some bubbles forming inside here. So it's starting to boil. So you've got some of the liquid water turning into vapor. So it's starting to boil. And in a moment, you'll actually start seeing that not only do we get boiling, but we're going to start getting freezing. So you'll be able to see, okay, here we go. Now we're at the triple point. You can kind of tell that it's a little bit solid at the surface. And so those bubbles are actually just underneath the surface. There's actually frozen water at the top. So we've got melting, freezing, and boiling all occurring at the same time. So this is a very unique situation for a chemical substance. So for water, this is what it looks like. But it is pretty cool that you can see it freezing and you can see it boiling and it's melting all at the same time. So that's the triple point of water, and you will see stuff with it at other times in chemistry class next year, but we won't be doing a whole lot anything with it this year. But I just wanted to expose you to that is the triple point, and I think the videos are kind of cool. So moving on to chapter 4. Last time and before spring break, we did some work with symbols and chemical formulas and development of atomic theory. We're going to review this a little bit today. And in going over our homework, then we're going to start talking about protons, electrons, and neutrons, as well as reading atomic numbers and mass numbers off of the periodic table. So here are the answers to the Niels Bohr video questions. I don't think anybody really had any issues with this, but please pause the video and take a look. The page 10 coloring sheet in your green packet. I noticed as I was looking at some people's coloring sheets, some of their parents didn't look quite like this parrot. So take a look and see if you got something wrong, maybe why. Part of the reason I like the coloring sheets is because it becomes very obvious if something is wrong, and you don't actually have to go through every item line by line. So if you have something wrong up in this corner, you should be able to go and take a look. And if you have something wrong in this corner, you should be able to also take a look. So as far as I'm concerned, we are done with this topic. If you need more practice, I did provide some additional practice in the additional Chapter 4 packet. There is a counting atoms worksheet as well as a counting atoms coloring sheet, and I think it's got like desserts on it, ice cream and things like that. It's just kind of a fun thing to check, to use again as a fairly easy thing. If you feel like you need more practice with this, please go ahead and take a little bit of time and look at those. We'll be coming back to this when we're doing balancing equations, so be sure that you feel pretty good about this. So we're going to start today with green packet, page 7, going over some of the atomic theory. So at the top, we've got a place for a definition of an atom. It's the smallest particle of an element that retains the properties of that element. And then it goes and starts talking about Dalton's atomic theory. We also watched a video that talked about Democritus and the beginnings with him. So not all textbooks start there. So the person I got this page from didn't start there, but Democritus is somebody who's actually kind of important because he really was the very beginning. So in Dalton's atomic theory, I believe your book listed 5 things. This sheet summarizes it down into 4. So all elements are composed of atoms that are indivisible. That is, they can't be created, divided, or destroyed. Number 2, all atoms of the same element are identical. Number 3, atoms of different elements are different. They always have different numbers of protons, and they may also differ in mass numbers. Number 4, atoms of different elements can combine with each other in simple whole number ratios to form compounds. And the bottom part of this indicates that once you have learned a little bit more about atoms, then you can describe some components of Dalton's atomic theory that have been modified. Well, number 1, I think you already know, because you already know that we have subdivided atoms into protons, neutrons, and electrons. So item number 1 has already been modified a little bit. Number 2, you don't probably know yet, or maybe you do. Atoms of an element do have some different versions, so they're not all absolutely identical. There are isotopes and ions, and we're going to talk more about these today and over the next few days as we work some more with them. So then we have the next thing was electrons were discovered in 1897 by physicist J.J. Thomson, and electrons are negatively charged particles that are found outside the nucleus. Dalton's model of the atom indicated that the atom was indivisible. However, Thomson's discovery of the electron led him to revise Dalton's atomic model. And Thomson's model is known as the plum pudding model, where you have this sea of positively charged areas with some individual negatively charged items here. This got modified by one of Thomson's students, Ernest Rutherford, and he came up with the idea of a nucleus. And his team of scientists ended up aiming a beam of alpha particles, which are helium atoms that have lost their electrons, so they're just a positively charged item, and they shot those at a sheet of a gold foil. And you guys saw a little simulation of that in the video that we watched 2 classes ago. And he found that most of these alpha particles passed straight through the gold foil and onto the detector on the other side. However, a few particles were greatly deflected and bounced back. So he concluded that most of those alpha particles pass through the gold foil because atoms are mostly made up of empty space. Not all of this stuff has something in it. Not this whole area doesn't have something in it. And so he believed that the mass and the positive charge were concentrated in a small region in the center, and he ended up calling this the nucleus. So he is the beginning of this idea of an atom having a nucleus. And then later on, protons and neutrons were discovered. So protons are positively charged particles, and they're found in the nucleus. Neutrons are neutrally charged or have no charge, and they're particles, and they're also found in the nucleus. So that kind of like summarizes everything coming up to date with the atomic structure development. So green page 11, parts of an atom. So this is a page for you to just completely fill out. Most of this, I believe, are things that you're already going to be aware of. So parts of an atom. All matter is made of tiny particles called atoms. Atoms are made of even smaller subatomic particles called protons, electrons, and neutrons. And then they have a sketch here of what it would look like. And they've drawn in here, they've got protons are positively charged particles in the nucleus that have a mass of 1 AMU. The number of protons determines the element of an atom, and for example, hydrogen has 1 and helium has 2. AMU is an atomic mass unit. Then also in the nucleus, we have a neutron. So neutral particles in the nucleus of the atom. They have no charge, have a mass of 1 AMU. Hydrogen is the only element that does not have at least 1 neutron in its nucleus. Then we have electrons, negatively charged particles in electron shells or levels. The mass of an electron is 1 over 1850. So It's very, very small compared to that of a proton. So it does not add any significant mass to an atom. So atoms are mostly empty space, and the mass comes from protons and neutrons in the nucleus. This guy says, wow, atoms are so small that the dot on this eye contains about 1 trillion atoms. That's a lot of atoms. So if you don't have this copied, go ahead and pause the video and go ahead and keep on copying. Moving on to page 12, you're going to copy the top portion, and later on at the end of class, you should be able to fill in the information that I have cut off here. There's just a couple of questions down here on the bottom of the page that I wanted you to attempt, but you'll be able to do it very easily, hopefully, after the end of class. So it says here, a substance that cannot be broken down into simpler substances by chemical means. An element is composed of atoms that have the same number of protons in their nucleus. Every element has a unique atomic number. It indicates the total number of protons in the nucleus of the atom. Normal atoms are electrically neutral. It has the same number of protons as electrons, so it's also the number of electrons. So when you look for the atomic number, this will give you the number of protons. The element name. Every element has a unique name. Many element names are very old and are based on other languages. Chlorine is named after chloros, the Greek word for yellowish green. Newly discovered elements are named by the discoverer but must be approved by an international committee. The symbol. Every element is abbreviated using a unique symbol of 1 or 2 letters. The first letter is always capitalized, and if there is a second letter, it is lowercase. Some are based on other languages. For example, the symbol Fe is iron from the Latin word ferrium. And it is very important that you always have the second letter in a symbol and in a lowercase so you can tell the difference. Also, we can see on our periodic table, there is an atomic mass. So atomic mass is the mass of the protons and the neutrons in an atom. Every proton and neutron has a mass of 1 AMU. Electrons do not count towards the mass because they are tiny. The mass can be shown with a decimal because it is an average mass of the isotopes of that element. So I'm going to be working through all of this, but this is kind of a reference page for you. All of the information that you need to know is pretty much on here, and we're going to work with this very specifically, very detailed as we go through and work on some more pages and understanding of how we determine each of these numbers. So let's start with protons. So what do you already know? I'm hoping that you realize that they're positively charged. They're located in the nucleus. Their mass is similar to neutrons and has a mass way, way larger than electron. New knowledge, maybe. Protons always determine the element because the number of protons is the atomic number. This idea is very, very, very important. I cannot iterate enough how important this is. This is one of those things, if you had an index card or a Post-it note, I would write this item on there and keep it handy as you are working on your assignment. So this idea, protons determine the element because the number of protons is the atomic number, is vitally important. So electrons, what do you already know? They're negatively charged. They're not in the nucleus. They are moving, and they're in some kind of region outside the nucleus. We can call it electron cloud. We can call it orbital. Right now, it's not that important. Where we call it, all the fact that we need to know is that it's not in the nucleus. And it has a very small mass compared to protons and neutrons, so we neglect to consider the mass of the electrons. So let's talk about charges. Information that you already know. If you have one positive and one negative charge, what do you end up with? Are they attracted to each other? Well, typically if you have one positive and one negative, they are attracted, and they end up neutralizing each other, so you end up with a neutral charge. What about if you have two positives and one negative? Your overall charge now is going to be positive because one of your positives will be neutralized by your one negative, but there's one extra positive charge. So now let's apply this idea of charges to protons and electrons. So in terms of atoms, protons are positive, electrons are negative. So if you have one proton and one electron, what do you end up with? I'm hoping you say neutral, because the one positive and the one negative in effect cancel each other out. What about two protons and one electron? Here you have two positives, one negative. Overall, you're going to end up with one positive. And in the last case, we have two protons and three electrons. In this case, we would end up with a single negative charge because you have three negatives and two positives. So, building on these ideas that I think you already are familiar with, anytime the number of protons and electrons are not equal, we will end up with a charge. It might be positive, it might be negative, and we call any atom or group of atoms that have a charge an ion. And this is part of the term in polyatomic ion that I mentioned briefly last time, and I said I'd cover more later. So, an ion is any atom or group of atoms that has a charge. So a single atom could be an ion, have a positive or negative charge, depending on the number of protons versus the number of electrons. Or you could have a group of atoms having a charge. These would be a polyatomic, meaning many atoms. So it's something that has a charge, could be positive or negative, and it's made of many atoms. So the most common polyatomic ions are the ones that I provided you a sheet before spring break. I will talk more about these, and we'll talk more about ions in a couple of days after we've worked with a little bit, some more of the basics. But this is kind of where we're heading. So neutrons, what do we already know? They're found in the nucleus. They have a mass similar to a proton, which is, again, much larger than an electron. They have no electrical charge, so they do not contribute at all to whether something has a positive or a negative charge because they're neutral. Atomic mass. Atomic mass, we only have protons and neutrons contributing to the atomic mass. We don't consider the electrons because the mass is so much smaller that it is not in the significant digits of our periodic table. Because as it showed, it was 1/1850th of the mass of a proton, which is really, really small. So if there is one proton and 0 neutrons, the atomic mass would be 1. If we have one proton and 1 neutron, the atomic mass would be 2. You have to remember that electrons do not contribute to the mass. So looking at a periodic table, and I just took a picture of some of it here, looking at it, the atomic masses listed are not whole numbers. Okay, based on what I just told you, if you're just adding whole numbers of protons, whole numbers of neutrons, you should end up with a whole number, and none of these are whole numbers. Why is that? So that is because we've got something else going on and contributing to this. So all atoms of hydrogen have one proton. It has an atomic number of 1. Based on the atomic mass of hydrogen that's given here in the periodic table, rounding it to a whole number of 1, we would say that the number of protons equals 1, the atomic mass equals 1, and knowing that the atomic mass is the number of protons and neutrons, we can determine that the number of neutrons equals 0. So on average, that is the case. But there are some forms of hydrogen that have different number of neutrons. So the 3 most stable and therefore the most common forms are protium, which has no neutrons and an atomic mass of 1, Deuterium, which has 1 neutron, and therefore the atomic mass is 2. Tritium, which has 2 neutrons, and it has an atomic mass of 3. These 3 different forms of hydrogen are called isotopes. They are all hydrogen because they all have 1 proton. But they have different numbers of neutrons, therefore they have different atomic masses, and they're in different abundances in the world. So they all contribute to this atomic mass being a little bit higher than actually 1. But the majority of what we have in the world is going to be this one that has an atomic mass of 1. I do have samples of these 3. I am not entirely sure how to share some of these, but I will try. I normally pass these around in class, but I will do my best to share those with you next class, or actually when we're talking about isotopes, which is actually next class. So, isotopes are different forms of the same element. They have the same number of protons, but have different numbers of neutrons, and therefore have different atomic masses. Some are more stable than others, some are more common than others. Some elements have lots of isotopes, some don't. They're all unique and different. So we're going to be spending the next couple of classes working with atoms, ions, and isotopes and figuring out the number of protons, neutrons, and electrons in each of them. This is what's going to lead us towards understanding reactions and formation of compounds, which is ultimately what you're trying to understand in chemistry. So, ladies, all this stuff was summarized on page 12 in your packet, as well as page 11 that we did at the beginning. But if you want to take any of these notes and have some of these, you'll kind of find as we work through some of the problems, what's going to be really helpful to you. So on your green packet, page 13, we're going to do a couple of these lines together, and then I'm going to have you work on the rest of this page on your own. So it's important that you look at this table and you say there are many lines in this table and each line is different. We have to take them one at a time. You are going to need your periodic table in front of you. If you do not have your periodic table, pause the video, go grab your periodic table or print it from P-Learning or pull it up on the internet, because you really are going to need that as you go through this. So I want to start with the first line. The first line is an item that has an atomic mass of 80. And we have to figure out what element has an atomic mass that rounds to 80. So grab your periodic table and take a look. Ladies, this requires practice. If you really don't do this with me as I go along, you're not going to be able to do this on your own. This is one of those you kind of look and watch and say, oh, yeah, that makes sense. But you have to really work on this as we kind of go through. And since you can pause the video, you can take it at your own pace. So determining all this information is very important for moving forward. So this is the second important topic that I need to cover this year. So atomic mass being 80, what element has an atomic mass that rounds to 80? So when I look at my periodic table, I kind of looked at these. I think that it's going to be bromine because this 79.904 rounds close to 80. So I'm thinking that it's going to be bromine and the atomic number is 35. So I'll be able to fill those into our table. So I've got bromine and the atomic number is 35. So standard atomic notation is something that we haven't talked about yet because we're just getting going. And this is where you fill in the symbol. And over on the left-hand side, you're going to put the atomic mass. And down here on the lower part, you're going to put the atomic number. So for our case, we're going to have bromine. The mass is 80. The atomic number is 35. Okay, so this is a standard way of writing it, and we'll get more into why we're writing it always like this, but this provides enough information for us to figure everything else out. So Number of protons is the number of your atomic number, so that's 35. To try to find the number of neutrons, it's the atomic mass minus the number of protons, which is 80 minus 35, which gives you 45. And the number of electrons equals the number of protons because it's neutrally charged, so it'll be 35. But a lot of times I get asked, how do you know that the number of electrons equals the number of protons? Because I talked earlier about ions. So they are going to always be equal unless there's some information telling you that there is a charge. So you have to be given something telling you that there is a charge. And this will be really obvious as we work later on. All of these for right now are going to be neutral. So you should end up with this kind of information on your line. Bromine, the standard atomic notation with the mass of 80, the atomic number of 35, the symbol for bromine, Br. The atomic number is 35, the protons is 35, neutrons is 45, electrons is 35. You can always do a quick check. 80 minus 35 equals 45, so we're good. So that was your first one. Let's do another one. Let's do the second line. So this time we know the atomic number is 6. So let's take a look at our periodic table and what element are we looking for? I think it looks like it's carbon. The atomic number here is 6. And so how much information can you fill out right now without my help? Pause the video for a moment and see what you can do. So could you get this far? The element name is carbon. The standard atomic notation is 12,6C. The mass is 12. The atomic number is 6. The number of protons is 6. So we still have to figure out the number of neutrons and electrons. So how did we do that again? Number of neutrons equals the atomic mass minus the number of protons. So it's 12 minus 6 equals 6. So that's our number of neutrons. Number of electrons equals number of protons. Neutrally charged equals 6. So this is a very unusual case where all of them are equal. You will run into it occasionally where you have protons, neutrons, and electrons are all the same, but that's not a common thing. So how did you do on this one? So this is what I have. So I'd like to look at one more on this page. So this one is the 5th row. I'm jumping down because I wanted to do one that had different information to start with. So the number of electrons here is 26. So we're kind of working backwards a little bit. So what can we do knowing that? Well, I'm hoping you'll say that number of protons equals number of electrons because it's neutrally charged. So that would mean our number of protons is 26 and our atomic number is 26. And then we hopefully can pull out our periodic table and figure out which element it is. So 26 would be iron, and it has an atomic mass of 56. So we can fill in our element name, and 56, 26 Fe, atomic mass is 56. So the only thing left is the number of neutrons, and how did we figure that one out again? Oh yeah, we know that the number of neutrons equals the atomic mass minus the number of protons. So that would be 56 minus 26, which equals 30. So we'll have the number of neutrons as 30. So this is what we've got. So how did that go? Hopefully it went okay. So we have done 3 of the 7 lines in this table. So I'm going to ask you to do the rest of these for finishing your classwork and to turn in. As you're doing these, I strongly recommend making a Post-it note with key information to help you remember the things that you have to do. So recommendations, keep your periodic table nearby. You can't do this without knowing what element it is in the having the mass number and the atomic number. Work slowly and carefully through each line, step by step. So a Post-it note with key information used to identify things. These are the things that I thought of. So atomic number equals the number of protons always, and this always identifies the element. Atomic mass is equal to the number of protons plus the number of neutrons, and that's always true. Number of electrons equals number of protons sometimes if the atom or molecule has no charge. For right now, we have no charge, and there's no column in our table for charge, so we don't have a charge. Later on, we'll have a table that has charges in it, and you'll see it later on in some class that you'll see some ions in there. Okay, so in finishing that up, you should also be able to go back to the bottom of page 12, where we left off the U try that was down here in the bottom. Please finish those up also because it has some information about electrons and neutrons. One other thing I wanted to talk about before I quit for the day. So polyatomic ions. I was asked in the survey last time if I will spend some more time going over those, and definitely I will, just not yet. What I wanted you guys to have the opportunity to do was to start recognizing that we had a few of these things that we were just going to have to memorize. So if I make the assumption that you didn't memorize them over spring break, I'm going to recommend that you try to memorize these 3 before the next class period. And I will introduce a couple more the next class period. And once we're kind of ready, I'll talk about the prefixes and the suffixes and how we get eights and ites and all of that stuff. But we're not quite ready yet. So nitrate is NO3 with a -1 charge. Bromate, BrO3 with a -1 charge. And ammonium, NH4 with a +1 charge. Ammonium is the only positively charged polyatomic ion that we are going to use and that you need to memorize. So everything else has a negative charge. So if you did not memorize them, try. It'll be helpful. Spending a few minutes here and there throughout the next 2 days trying to get these 3 polyatomic ions solid in your own brain is going to be really helpful. So turn in work due Wednesday. So we're going to turning everything in the next day we have class. So pages 7, 11, 12, and 13 should be complete before you start the next class. And I do have a survey up there, and you really do want to have kind of finished page 13 before you go through and wrap up for the day. So finish page 13 and then fill out the survey. So the book work, optional book work. I had mentioned previously 4.4 and 4.5 with some questions. Some of the things that I went over today are actually in 4.6 and 4.7, and these are the questions that I normally would have students do for reading. Since we're trying to cut back on the amount of time that you're spending, it's up to you whether you feel like the book work would be helpful to you or not. And I am posting those answers out on P-Learning. So looking ahead, we've finally started some of our real chemistry. Math videos have started. They will be in your Edpuzzle. But they're not going to have any due date. But I'm going to assign them, but they will be out there for you to watch if you choose to. Needing candies, I will have you building some models of elements, and you'll need 3 different colors of small candies, kind of like what I mentioned before break. I am not decided whether we will need those Wednesday or not. I don't think so, but we might be able to use them Wednesday. So that's kind of where we are. So ladies, I think that was it. Yeah, that was it for the day. So Ladies, I've missed seeing all of you, and I appreciated all of you who stopped in to chat with me on Zoom before spring break. And I hope that this was fairly clear. If you do have questions, feel free to contact me using the survey or sending me an email. And good luck returning to school. Talk to you guys soon.